Hello students, myself Swapnil sir, your favorite mathematics teacher, and welcoming you all back to yet another video on our channel. Already we have started lecture series based on the different topics from mathematics. Already I have uploaded plenty of the videos on my channel. So if you are interested to see this video, do check in my playlist. So in my today's video, I'm gonna explain to you all one of the very much important topic from mathematics, which is the mensurations. So in my today's video, first of all, I'm gonna explain to you all the basic concept, all overview, and at the end we go for solving some important questions based on your upcoming exam. Now, first, most of the student you all are feeling like mensuration, it is quite bit difficult to understand, or they are having a lot of formulas and so many things you are having in your minds. Okay, but as I felt that these are the very much easier topics, but just a matter here to understand the concept and formulas. So in my today's video, I'm gonna explain to you all a trick along with some of the hint that you can remember this formula for your lifelong. So without further ado, let's get dive into our today's lecture. Now this one is lecture completely based on the mensuration chapter. Okay, so let's start our part of the mensuration. Okay, so what actually meaning of a mensuration? Okay, let me explain meaning of a mensuration, what we are going to learn under mensuration chapter. Okay, the mensuration chapter, it is the branch where we study different type of the plane figure, different type of the solid figure, their area, curved surface area, like parameters, after that circumference, volume, total surface area, all these concepts comes under mensuration chapter. Okay, so mensuration generally it divide into the two parts. First part it goes to the plane figure, and second another part it goes to the solid figure. Okay, what we have dividation of mensuration? Plane figure and second a solid figure. Okay, so why we call it as a plane figure? Because we can plot plane figure into the two-dimensional space like x-axis and y-axis. Okay, and solid figure, that means it is having three sides. When we look from front side, we can see it's a three sides. That's why we call it as the three-dimensional space. As we have for a plane figure, x and y axis are the two plane. Okay, as a 2D plane. But when we have to deal such a three-dimensional figures like x-axis, y-axis and z-axis, three-dimensional figure, that time we consider the solid figures under 3D space. Okay, now what are the major difference between plane figure and solid figure? Let me write first of all the two different part of a mensuration, which is the first plane figure, plane figure. Okay, first one it is the plane figure, and second it goes for the solid figure. Okay, a solid figure. Okay, what are the major difference between plane figure and solid figure? Okay, actually plane figures are in the we can plot plane figures into the two-dimensional space, and solid figure we need at least a three-dimensional space. Okay, that means three-dimensional space only we can plot the solid figure. Okay, so we can plot plane figure into two-dimensional space, like as you all have learned under coordinate geometry. Okay, so in our coordinate geometry we have learned x-axis, y-axis, how to plot the plane figures in it. Okay, in a three-dimensional space we can plot different type of the solid shapes. Okay, now for a plane figure, what we have to deal specific concept. Okay, now let me tell you first concept here, which is the area, like area of a triangle. Okay, area. Okay, area which we can use for the area of a triangle, area of a parallelogram, like area of a rhombus. These types of the plane figure we consider it for the area. Okay, okay, and next part we have here area, after that second perimeter. Okay, perimeter. Okay, First area, second it goes for the perimeter, third we consider for circumference, like a circumference of a circle, okay, like a diagonal. These concepts are also be the part of plane figure, okay. So for example of a plane figure, let me explain example of a plane figure. Now we can see here triangle, okay. Let's consider a triangle. It is also the plane figure that we can plot three vertices into our x and y axis, okay. So we consider it as the two-dimensional figure. After that we consider circle. Now see that this one is our circle, okay. This one is also the part of a plane figure, okay. Like you can go for the parallelogram, okay. You can see parallelogram, it is also the plane figure. Now in these plane figures we have to deal mainly perimeter, area, circumference. This type of the concept we have to understand under a plane figure, okay. Now let's move for the solid figure, okay. What actually meaning of a solid figure, and what are the shapes comes under the solid figure, okay. Yes, about the solid figure, that means the figure which we can plot into the three-dimensional space, okay, 3D space. That means x-axis, y-axis and z-axis, okay. We have three-dimensional space, then we can easily plot solid figures, okay. Now let me explain when we go from plane figure to the solid figure, okay. From plane figure to the solid figure, what are the major point we have to study under solid figure, okay. First it is a volume. Obviously it is a volume, okay. What we have to deal here? Volume, okay. Now secondly we know that the surface area, okay. So surface area, it is not like a we consider we have solid figure only one surface area. That surface area majorly it divided into the curved surface, like a curved surface, lateral surface, total surface, okay. Now we have here under surface area, which is a curved surface area, okay. That means curved surface area also we call it as the total solid lateral surface area, okay. Lateral surface area, okay. Curved surface area we call it as the lateral surface area too, okay. And the curved surface area, lateral surface area, all the surface which are present in our solid figure, when we add all of these surfaces, we get the total surface area, okay, which gets under the surface area. What we have? Total surface area, okay. This one is our surface area, okay. Curved surface area, total surface area, lateral surface area, okay. This concept we have to understand here in our today's lecture, okay. Now see that this one is only as our recap video. So I'm not going to go for detailed explanation or detailed solving of the topic here. I will explain to you all only what part we have to remember, okay, what you all have to focus, that when we are here for this, okay. And if you are interested to see detailed video, let me know in my comment section. I will come up with the similar video. And if you wanted to see tricks, how can we remember this formula for long time, okay, or you can remember it for lifelong also. For that you have to watch one more video, okay. So if you're interested to see this video, see that video, do check in my playlist, okay. And if you want more videos similar like this, let me know in my comment section, okay. Yes, these all figures comes all concepts comes under solid figure, and this comes under plane figure, okay. Yes, now let me explain which are the solid figures, which are the plane figure. You all are familiar with the plane figure right now, okay. So plane figure like a triangle, circle, okay, parallelogram, rhombus, this kind of a figure, you consider it as the plane figure, okay. Now what about for the solid figure? Let me explain with the solid figure now. A solid figure, okay. Okay, let me explain with the explain some of the concept from the solid figure. Okay. Yes, solid figures means at least we can see three sides from our front face. Okay. Now, if I'm going to see from my front side, I have to or that figure has to visible from its three side. Okay. Then we consider it as the solid figure. Okay. Yes, or three-dimensional figure also we call it as. Okay. Now, let me explain with some of the example. First, I consider here. Okay. Let me consider first as a cylinder. First, I consider here as a cylinder. Okay. Okay. Now let me plot cylinder, how it look like. Okay. Cylinder means we have hollow shapes, solid figure. Okay. Now we can see this one. We have a cylinder here. Okay. This one, it is a radius, and this one is the height. Okay. Yes. Now this one, we have a cylinder here. Okay. I know that you all are familiar with these types of the shapes. Okay. So this one is the cylinder having height h, radius r. Inside part of that cylinder, we generally consider it as the volume. Okay. Now let me explain with one shape. Okay. Okay. I will explain to you all with one shape what we consider as the cylinder. Okay. Now see that it is like a cylindrical shape. Okay. You already have seen cylinder. Okay. So as it is the part of our daily life, I don't have to explain much. Okay. But you all need to see how the cylinder look like. Okay. Now see that this one is like a cylindrical shape. Okay. Like it's a curved surface area, it is here. Now this one we have top area, this one we have bottom area, inside hollow part we have here. Okay. Now see that inside part we consider it as the volume. Okay. Now volume, how we define volume in the case of a solid space or a solid figures. Okay. Volume generally we define like how much water we can pour inside that cylinder. Okay. Or how much space we have inside here in that cylinder. We consider it as the volume for our cylinder. Okay. Yes. That's it for the volume. Now let's go for the another concept like a curved surface area or lateral surface area. Now see that in our mathematics, what we have to do, we have to fill the concept. Okay, using their names. Okay. Now see that from a rounded part here, as we all can see the rounded part from all the sides here, you can see all up to the bottom. It is completely rounded part. We consider it as the curved surface area or lateral surface area. Okay. So we call it as the curved surface area or lateral surface area. Both are having equal meaning. Don't get confused between these two words. Okay. Curved surface area and lateral surface area, both are the same here. Okay. In most of the case, you will get the what is the curved surface area, and most of the case you will get question like what is the lateral surface area. So be focused. Both are the equal word or both are having same meaning. Okay. Yes. This one we have curved surface or lateral surface area. Now what about for total surface area for our cylinder? Okay. What about for total surface area? Total surface area, that means you have to count it everything around your cylinder. Okay. Everything around its cylinder means we have to count first of all curved surface, lateral surface area everywhere here. Okay. Plus area of a top, we have circular shape here, one circle. Okay. Area of a bottom, it is also a circle. Okay. It is also a circle. That means total surface area we count as the curved surface, lateral surface area plus area of a top plus area of a bottom. Okay. In a cylindrical shape or in a solid shape, we consider curved surface area, lateral surface area as a 2 pi r h. Okay. For our cylinder. And a volume of a cylinder, we write pi r square h. Okay. But it is having its own meaning. I will explain you all everything, but just hold on. Okay. Let me explain some concept. At the end, I will explain to you all how can we construct this formula by ourselves. Okay. We don't have to rely anything. We don't have to recite the concept. Okay. We have to remember formula or we have to create formula by ourselves. So I will explain that to you all. Just hold on for a few minutes. Okay. Yes. Now this one we have cylinder. Okay. As you all are familiar with all the concepts from here. This one is a curved surface area or lateral surface area. This one is the area of a top. This one is the area of a bottom. Okay. This one is the area of a top bottom. Now after that cylinder we go for cone. Okay. Cone, we all are familiar with the cone. Okay. So you all have seen the birthday cone. Okay. That we wear like a cap. Okay. This one is the part of a part of the cone. Okay. After that, which more example we have here? Yeah, we eat like ice cream. Okay. So ice cream size shape we also found one. I also found one cone there, and you all are already familiar with that. More than me, maybe you all are more fan of ice cream. Okay. So you can see the cylindrical shape there in a cone or birthday cap also. Okay. Now see that the conical shape, it look like this way. Okay. Now see that this one I consider here. Okay. Just for your better understanding, I'm trying to make here solid shapes here. Okay. Trying to make solid shapes here. Now see that this one we have cone. Okay. Just consider this one is a cone. I am not able to build that cone. Okay. But you all have to understand this one is the cone. Okay. Let me build the cone for you all. Yes. Yes, this one we have cone at one side, one area of our cone, which is the just a single point, and another we have it's like a circular shape. Okay. So let me write second what we are going to learn. Cone. Okay. Now see that cone, it is like a birthday type cap. Okay. Cap of a birthday. So this one, it is a center, it is a height. Okay. So when we have that this one is the height, this one is the radius, and when we have that lateral or it's like a slant sides slant type of a height, we consider it as a slant height in our cone. Okay. What we call for it? Slant. What we call for it? A slant height. Okay. Slant height as a edge. This one we have top point, that means it is a single point. Okay. Point circle it is there, but we cannot count it as the part. Okay. So it is actually the point, and we don't have to find out the area or any other concept for this. But from downside part here, area of bottom here, we can see we got the one circle here from downside part. Okay. Now let me show you with the figure. Okay. Now see that I do have one cone here. Okay. Yes. Now we all can see this is the conical shape. Okay. This one is the conical shape. Now we can see at the part of a down bottom here, which is only a single point. When we go for the part of a top part of our cone, which is like a circular shape. Okay. It is like a circular shape. Okay. So we consider it as the circle. This one is a curved surface area or lateral surface area. Now we can see that all are here curved part. Okay. Curved part for our cone. So generally we call it as the curved surface area or lateral surface area. Okay. And what about for the volume? What about for the volume? Similar like a cylinder, we have to understand the concept for cone. Okay. The inside part of that cone. Okay. That means how much water we can pour inside that cone. Okay. So we consider this one as the volume of cone, that inside part here. Okay. Yes. This one is the volume of a cone. Now what about for total surface area? Now we come to understand, we understood now area of a top, area of a bottom, curved surface area, lateral surface area. Now what about for total surface area? Now in the case of a cone, total surface area, it defined as area of a top, as we don't have anything from a bottom here, so we cannot consider anything from bottom. That means area of a top plus area or curved surface area or lateral surface area. Okay. Area of a top plus curved surface area plus lateral surface area for this cone. Okay. Yes. So in the case of a cylinder, we have volume pi r square h, and we have total surface area or curved surface area. First lateral surface area we have here 2 pi r h. Okay. curved surface area or lateral surface area, we have 2 pi RH, and total surface area means area of a top means it is a circle, that means area of a circle which is a pi r square. Area of a bottom, it is also pi r square, that means top area, bottom area 2 times pi r square, plus area of a or curved surface area or lateral surface area which is a 2 pi r, okay, 2 pi r into h, okay. So we all have to add everything, you will get the total surface area for cylinder, okay. Now what about for cone? In the case of a cone, when we divide that cylinder into 3 parts, we get the volume of a cone as a 1 by 3 pi r square h, okay, 1 by 3 pi r square h, okay. And plus curved surface area, lateral surface area, that means we have to look out for the only the rounded part. So we write a total curved surface area which is a pi r l, okay. Curved surface area is a pi r l. Why l? Because l, it is here as a slant height. L we have here as the slant height, and slant height we can define by using Pythagoras theorem, which is a very much important in mathematics, okay. So Pythagoras theorem, actually it says that hypotenuse side square which is equal to addition for remaining 2 side square, okay. So what is the Pythagoras theorem? It says that hypotenuse side square which is equal to addition for remaining 2 side square, okay. Yes, this one we have Pythagoras theorem here. Yes. Now after that we have total surface area, that means area of a bottom, area of a top plus curved surface area, okay. That's it for the cone. I'm expecting that you all have understood everything for cylinder and cone. Let's move for the next solid figure. Next solid figure, which is a sphere. Third solid figure, which is the sphere. How many of you all have seen sphere? Give me an example in my comment section. What are the types of sphere? What are the figure that you have seen in your daily life? Okay. Let me know in my comment section which are the figure that are the spherical shape, okay. Okay, now let me explain some of the example here, okay. Like a football shape, we consider it as the sphere. Like a volleyball shape, it is also the sphere. Give me more example in my comment section, okay. So sphere, what we have sphere here, it is like a spherical shape, and we know that spherical shape, it is like this, okay, like a volleyball or football shape. This one is the spherical shape, we can see it here, okay. This one is the center, this one is the, okay, we have a sphere here, okay. Yes. So let's go for the sphere now, okay. Oh, now about sphere, we have center here, radii here. Radius and height in the case of a sphere both are equal, okay. Both are equal in the case of a sphere only. Now we can see this one is the height here, but actually height it is also radius in this case of sphere, okay. Now we know that it is a spherical shape. So if it is a spherical shape, that means volume of a sphere, it is a inside part, completely inside part of that sphere, okay. And when we take 4 cone together, we get the sphere, okay. So what is the volume of a sphere? Volume of sphere, okay, which is a 4 by 3 pi r square h. 4 by 3 pi r square h, okay, which is the volume of a sphere here, okay. Volume of a sphere, what it says, which is like a spherical shape, and we have to find out its volume. That means inside part, how much we have inside part there. That means if you are going to pour the water inside the volleyball or football, that we have to find out how much water we can pour at a time, okay. So we consider this one as the volume of a sphere as the 4 by 3 pi r square h, okay. Now let me explain curved surface area, total surface area in the case of a sphere, okay. Yes. Now in the case of a sphere, curved surface area, total surface area, both are equal. Curved surface area, total surface area, lateral surface area, both are equal. Why it is equal? Because it is a rounded shape. It is all rounded shape. It do not have like another area. It is only complete one single area we have here, which is only curved surface and total curved surface here. Okay, we don't have another area which available in our sphere. Okay, yes. Now we have to find out the curved surface, total surface or lateral surface area for this sphere. Okay, so it is defined as the, now we can see that H, it is the first of all, let me write the volume, okay, in the another form, because in the case of a sphere, volume and radius are equal. That means we write 4 pi r square into r. Okay, that means we write a 4 by 3 pi r cube. We write it is the 4 by 3 pi r cube as the volume for our sphere. Okay, yes. And now curved surface area, total surface area or lateral surface area, we write 4 pi r square. Okay, we write it as the 4 pi r square, which is the curved surface area or lateral surface area. Okay, now let's go for the next. After sphere, we have to go for the hemisphere. Okay, so what is mean by actually hemisphere? Okay, let me draw with one figure, as we have this pair here. Okay, let me draw the figure. Okay, yes. Now we can see we have sphere here. This one is, it is a center. Okay, it is a spherical shape. Consider this one. This one is the spherical shape. Okay, let me plot. Okay, this one, it is look like a spherical shape. Okay, yes. Now we learn already about a sphere, everything. Now let's go for the hemisphere. Let's go for the hemisphere. Okay, what actually meaning of hemisphere? When we cut sphere into the two equal part, when we cut sphere into the two equal part, both part needs to be equal. Okay, so I do have a sphere here. I'm going to cut this sphere into the two part. Okay, but both part it has to be equal. Then we consider one part as the hemisphere. Okay, so let me cut this into the center. Okay, so then we'll get the equal as a upper part and a downside part. Okay, so our downside part, it goes like this. Yes, when we cut sphere into the two equal part, we get the hemisphere. Okay, this one is a radius. Okay, yes, radius and height in the case of a hemisphere, both are equal. Okay, yes. Now we can see that in our hemisphere, okay, we write the volume, that means half of the volume of a sphere, which is a hemisphere. Okay, and what we learned about the volume of a sphere, let me show you all. Okay, volume of a sphere, which is a 4 by 3 pi r square h. Okay, and if you're going to take half of this volume, you will get the volume of a hemisphere. Okay, so what we get, it is a 4 by 3 pi r cube, which is the volume of a sphere. Okay, and now we want half of the volume for our sphere. Then we write it as the 1/2 multiplied by 4 by 3 into pi r cube. Okay, this is the actual volume of a hemisphere. Volume of hemisphere. This one is the volume of a hemisphere here. Okay, yes. Now divide this one, 2 to the 4, so 2 by 3 pi r cube, which is actually volume of a hemisphere here. Okay, now I hope you all have understood the meaning of hemisphere and the volume of hemisphere here. Okay, now what about for total surface area, curved surface area, lateral surface area? Are total surface area, curved surface area and lateral surface area all are equal here in the case of hemisphere? No, exactly no. The surface area, total surface area for hemisphere, curved surface or lateral surface area, they never be equal. Why they never equal? Because we have area of a top here, area of a top which is a circle. Okay, area of a top we have here, downside part we have a circular part, that means curved shape we have downside part, that means the curved part of a hemisphere we take this one only. Okay, downside part. And after that, total surface area means area of a top. Okay, area of a top plus curved surface area plus curved surface area like a lateral surface area, and plus a bottom part means area of a bottom. But as the part of a hemisphere, or we do not have bottom. Okay, that means we do not have any area present in a bottom. Okay, so we write area of a bottom, it has the 0. Okay. Yes. Now we have volume of a hemisphere, then curved surface area or total lateral surface area, we write a 2 pi r square. Okay, this one is the curved surface area or lateral surface area. And what about for total surface area? Total surface area means curved surface area, lateral surface area plus area of a top plus area of a bottom. Bottom do not have anything, so area of a top, it is a pi r square, which is a circle. Okay, that means 2 pi r square plus pi r square, which is a 3 pi r square, which is the total surface area for our volume. Okay, that's it for our solid figures. Okay, one more we have like a cuboid, cube. These two solid shapes still remaining. Okay, so I will do explain both of them. Okay. So I hope you will have understood these concepts. Okay, let's move for the one more. Two more solid shapes are remaining. Okay, which are cube or cuboid. Okay, which are cube or cuboid. Okay, what actually meaning of a cube and cuboid? What are the difference, major difference between them? Okay, what's look like a little bit similar. Okay, that means figures are likely to be similar. Okay, like a cube and cuboid, both are having similar type of figure, but they are not equal. Okay, so there is a difference between similar word and equal word. Okay, they look like similar, but they are not equal. Okay, now let me explain about the cube. Okay, so I do have figure here of a cube. Let me plot the cube first. Okay, this one is our cube here. Okay, now see that this one is a cube. Let me plot the cuboid also. So as my drawing, it is not that good, but you all can understand. I hope. Okay. So this one is the cube. This one we have here. Okay. This one is the completely cube, and this one we have cuboid here. Okay. So what are the major difference between cube and cuboid? Okay. So in the case of a cube, we write length into breadth into height, all are equal. In the case of a cube, length, breadth, height, all are equal. But in the case of a cuboid, length, breadth, height, both are, all are three of us are different. Okay. So this one is the major difference between cube and cuboid. Okay. So what are the major difference? Length, breadth, and height, all are different in the case of cuboid, but in the case of a cube, all are equal. Okay, that's it, the difference, major difference between cube and cuboid. Okay, so now we can see that this one is the height here for cube. Okay, this one is the breadth, this one is the length. Okay, all are equal in the case of a cuboid, in the case of a cube. Okay, so this one is the height, this one is the breadth, and this one is the length. Okay, yes. Now, what about for volume? What about for volume of a cube or cuboid? Okay, volume of a cube, we write length multiplied by breadth multiplied by height. Okay, we write length multiplied by breadth multiplied by height in the case of a cube and in the case of a cuboid. Okay, but as we know that if three of these are equal, then we write length which is equal to A, breadth which is equal to A, and height which is equal to A also. Okay. That means we write volume of a cube which is a cube. Okay. And what about for the volume of a cuboid? length into breadth into height. Okay, what we have volume? Length into breadth into height. Okay, but three of these are not different, so we cannot multiply them directly till we are not getting their values. Okay, yes, that's it for the volume of a cube and a cuboid. Now let's move for the total surface area and curved surface area. Okay, yes, what about for total surface and curved surface? Now see that, let me explain with one example. Okay, I do have one mouse here. Okay, just consider it as the cube. Okay, cube or cuboid. So about the curved surface area, total surface area for a cube, it is different. Okay, don't consider it as all are equal. Okay, yes. Now see that for this side, left right side, we have two surface areas. Okay, front back side we have two surface area. So curved surface area, it gives us the value front back side plus left right side. Okay, this one is the curved surface area. But remember, note it down here, area of a top, area of a bottom, this we cannot consider as the part of curved surface area or lateral surface area. Okay, the meaning of a curved surface area, lateral surface area, we have to delete the part from top, part from bottom. Okay, only add the part, left right side part, front side part and back side part. Okay, these all are the part here for our cube or cuboid. Okay, in the case of a cube, we know that length into breadth, we consider that as it as the edge here. Okay, so we write a surface area, curved surface area. In the case of a cube, which is the, we have all the four sides. Now we can see that first, second, third and fourth, we have total four side. Okay, 4 into a square. Okay, 4 into a square, which is the curved surface area in the case of a cube. Okay, and total surface area means area of a top, area of a bottom, left right side area and front and back side area. Okay, total how many sides we have here? Total surface, in the case of total surface area, we have total 6 amount of sides and length into breadth. We have to add this one here. Okay, this one is the total surface area. Yes, similarly we have to use it here, like for curved surface area, length into breadth, breadth into height, height into length. Okay, yes, this way we have to follow for cuboid also. I'm expecting that you all have understood all these solid shapes. Okay, so if you want any trick or a separate video for this solid or plain figure, let me know in my comment section. Okay, I will come up with a separate video with some of the tricks. Okay, so I'm expecting you all have understood everything. Let's move for some of the examples from based on these all concepts. Okay, now we have to practice some examples. Yeah, surely, because after understanding the concept, we have to go for some example. Okay, that will be more helpful to understand the concept here. Okay, so different formulas you all have learned for solid figure, solid shape and plane shape. Okay, you all have learned for solid shape and plane shape. Okay, like a solid figure and plane figure. Let's move for some of the example. Okay, yes, I do have first example here. Which one of the following is the ones of a rhombus? Now see that question. It is quite bit confusing. Most of you all have think that it's maybe thinking that it is literally difficult. We cannot go for that question, but in actual, it is nothing. Just in one step, you will get the answer. Okay. In your exam, whenever you feel that question, it is quite difficult, confusing, I cannot attempt this, I have to leave that question, but exactly that is the question, it will give you correct and easy marks. Okay, they are just looking difficult, but don't judge any book by their covers. Okay, don't judge any question by their outer part, try to understand it. Okay, you will get the perfect solution. Okay, once you have to understand it first. Okay, once you come to understand, next part is easier. Okay, yes, let's move for the solution of this. First of all, rhombus given. Let's plot the rhombus here. Okay, how rhombus look like? Okay, let me plot the rhombus. Yes, Okay, so it is not look like little bit rhombus. Okay, let me plot some another one here. Curve, we want the curve. Okay. So not able to get plot this one. Let me plot by myself. Okay. Okay, this one is a little bit, yeah. This one is our rhombus. Okay, consider it as the rhombus. Okay, so here it is the first diagonal and second diagonal we have here. So A, B, C and D, we have here A, B, C, D as the rhombus. Okay, diagonal first D1 and second diagonal D2. Okay, as we have it's a rhombus, that means we have two diagonals which intersecting at a certain point. Okay, it is A, B, C, D are there are four vertices. Okay, yes. Now that's it. We understand it here. Okay. Now, what about for the next part? How can we judge which one of the option is correct? If you are going to observe all these options carefully, you can see that this is the standard result for rhombus. Okay, this one is the standard result for rhombus. Okay, so what is the standard result for rhombus? Which is the area of a rhombus. Okay, what is the area of a rhombus? It says area of rhombus. Okay, this one is the actually standard form for area of a rhombus. Okay, and we know that area of a rhombus we write 1/2 into first diagonal multiplied by second diagonal. Okay, that means area of a rhombus, it says that 1/2 multiplied by a multiplication of a remaining two diagonals. Okay, now see that here in my first option product of its diagonal never possible because one of it is there. Okay, two times product of its diagonal it is also not there. Okay, because we have 1/2 into product of diagonal and 1/2 into sum of its diagonal not there. Okay, we have product. So our correct option, which is option number B, which is the area of a rhombus, which is a 1/2 into first diagonal multiplied by second diagonal. Okay, very much important question. Be prepared with this. Okay, I'm expecting you all have understood this solution. Let's move for the next question. Okay, the age of a cube is a 1 centimeter. Then which one of the following it is a volume? Okay, yes. Which one of the it's a volume? It is actually not meter, it is given in the meter cube. Okay, it is a centimeter cube. Okay, it has to be the centimeter cube. It is a typo here. Okay, now let me plot a cube first. This one is the shape of a cube. This one is the shape of our cube here. Okay, yes. Now age of a cube, it is it says that we have to multiply breadth into the length. Okay, so length into breadth, which is the age of a cube. Okay, so we have given one side of age of a cube, it is given, it is a 1 centimeter. That means we write volume of a cube as a volume of a cube as a cube. Okay, volume of a cube as a cube. That means we have one age, it is given 1, it is length into breadth, we get the 1 into 1 centimeter square. Okay, so how we get 1 centimeter into 1 centimeter? Okay, we get the 1 centimeter square. Okay, for it's a two-dimensional space. Now volume of a cube, which is a 1 centimeter cube. Okay, that means 1 centimeter cube means 1 centimeter cube. That's it only. This one is our correct answer, and option 4 gives us a correct answer. Okay, that's it for our solution. Okay, just you all have to understand what is meant by the cube. Okay, the parallel sides of the parallelogram are given 2 centimeter apart, and their sum is a 10 centimeter. Okay, now see that little confusing, but the parallel sides, their length and their sum are given. Okay, sum and length of a parallel sides are given. Let me plot the parallelogram first. This one is our parallelogram. Consider A, B, C, D. Okay, this one is a D. This one is first diagonal. This one is a second diagonal. Okay, yes. So parallel sides are out 2 centimeter apart, okay, and their sum is a 10 centimeter. That means if you're going to add the two parallel side, we get the 10 centimeter as their value, okay. So that means we have parallel side AB parallel to line segment DC, okay. What we have? Line segment AB, which is a parallel to the line segment DC, okay. And another we have here line segment AD, which is a parallel to line segment BC, okay. These two conditions we have here. And if we have two line segments are parallel, then we consider they are equal in a measure, okay. So let's consider equal in a measure in the case of only parallelogram, okay. In the case of parallelogram, so consider line segment AB, which is equal to line segment DC, okay. Line segment AB which is equal to line segment DC. In the case of a parallelogram, these two sides are equal because of they are parallel, okay. And next condition we have here, the addition of these two sides, okay, sum of these two sides is a 10 centimeter, okay. That means addition of these two sides are 10 centimeter. That means AB plus DC, which is equal to 10 centimeter, okay. Yes. Now we have two sides, they are equal, okay. That means AB plus AB, which is equal to 10 centimeter, okay. Now we can see that both are the equal side. That's why I replace DC as a AB. So AB plus AB 2 times AB, which is equal to 10, and AB we get the 10 centimeter square, okay. So we get the AB as a 10 centimeter square, which is the correct answer, okay. What we want here, the parallel side of the parallelogram, then the area, okay. So I hope you all have understood this solution, okay. Let's move for the next. The area of a cube is a 1 centimeter, then which one of the following is a total surface area? Now you all have to understand total surface area of a cube, okay. What is the total area of total surface area of a cube? What is the total surface area, which is a 6 times a square, okay. And we have 6 times one edge, which is given as the 1 centimeter square, okay, 1 centimeter square, okay. This one is the next. That means we write a 6 centimeter square is the total surface area for our cube, okay. Now see that how easy these solutions are, okay. We just have to understand what we have given in our question. We will get the required answer easily, okay. It's not that difficult. I hope you all have understood this solution, okay. Let's move for the next question. Which one of the following is equal to 1 kiloliter, okay. It is actually question based on the measurement, okay. So you all have to be familiar with the all type of measurement: liter, gram, kilogram, kiloliter, hectoliter, deciliter, plus meter, kilometer, centimeter. All these measurement you all have to be familiar, okay. So do prepare this one. So 1 kiloliter we write 1000 milliliter, okay. This one is the right answer. So you all have to understand this part. So this one is our complete part of our lecture, okay. So that's why I hope you all have understood everything from my today's lecture, okay. Nothing it is difficult. Even after, if you found anything difficult, let me know in my comment section, okay. So what we have learned so far in our today's lecture, okay. First we have started with the plane figure, curved figure, yes. Then we learn about plane figure, area, perimeter, circumference, everything, okay. And about the solid figure, we learn cube, after that a cuboid, after that cylinder, cone, sphere, hemisphere. All these concepts we learn in our today's lecture. I'm expecting that you all have understood everything from my today's lecture. So if you found it helpful, do comment in my comment section, okay. This one will be the really big motivation for me, okay. So thank you everyone. Thank you for my today's lecture.